Okay, so the last two techniques we're going to talk about today are grouping and chunking. Okay? These are really not hard to do, and actually I kind of enjoy the grouping one. I think it's kind of fun. So, first of all, I want to give you two examples, and then I'm going to have you guys practice a couple, and then I'll give you some more examples of chunking. So this first one, what I want you guys to notice is that there's how many terms on this? Four terms. You are going to use grouping when there are 4 terms. That's important to remember. Yep. Okay? You will not use grouping in any other way. Just with 4 terms. Okay? So, I'm going to pair up 2 sets of terms. Those 2 right there, and those 2 right there. Okay? So, if I were to rewrite this, I would write this as t to the third minus 3t squared plus negative 4t plus 12. Okay? What we're going to do is look at the first group. What greatest common factor can I take out of that?
T squared.
T squared. So if I take out a t squared, I am left with t minus 3. Good.
Because
It has a negative right here. Okay?
you can take out a 4.
Yes, I could take out a 4, and what else? Is that it?
That's it.
Okay, so if I take out a 4 out of here,
Negative t plus 12.
negative t plus
JK plus 3.
3. Now, notice that these 2 terms right here are not exactly the same, and I need them to be the same. What can I do to the second grouping to make that,
Negative 1.
yep, take out a negative 1, okay?
Take out or put in?
Take out. So if I take out a negative 1, this becomes minus 4. And then what's inside now is,
Wait, why are you taking out a negative?
so I can change my signs.
How do you take out a negative?
You multiply by 1.
Okay?
You just make the outside sign negative.
So notice that that became negative so that I could change my signs on the inside. Okay? So notice that they both have a t minus 3 now. So I can take a t minus 3, and then whatever's left over goes in my other one. So I have, yep, I have a t squared and a minus 4.
Yeah. And t squared minus 4.
Okay, so I took out a t minus 3 because they both had one.
Okay.
I put it there, and then whatever was left over, they're circled, goes in this.
Okay.
Now, this can be broken down because this is using the difference of squares. That's what you learned last week. Remember, this is that conjugate factoring thing, okay? They're perfect squares. So this would be the same as saying t plus 2 and t minus 2 and t minus 3 here. Okay, so on this one, I'm going to put these 2 together and these 2 together. So it'll be 27 x to the third minus 45 x squared, and that's going to be in one group, plus negative 12x plus 20. Okay, so what can I take out of the first grouping? Bigger than a 3. 9x squared. So this will become 3x minus 5. Okay? What can I take out of the second grouping? A 4. So I have 4, and then I have 3x, negative 3x, plus 5. Are those 2 terms exactly the same?
No.
So I'm going to do the same thing I did before, take out a negative. So this become a minus 4 in front instead.
You could do the same thing on the other side, right?
Yeah, you could. Yeah, right. You could have done it on the other one. But I'm doing it this way just because it's easier for me, I guess. Okay? So notice that they both have what in common? 3x minus 5. So I'm going to write that here. 3x minus 5. And then what's left over? Okay. Now, can I continue factoring this? Yeah.
3x plus 2.
Yep.
3x minus 2.
Yep.
Oh yeah. Could you potentially, if you saw?
Okay, so now we're getting into chunking. Okay, chunking basically means I can kind of replace this with a simpler way of factoring. So So notice that this is x squared plus 4x to the second power plus 7 times 4x to the second power plus 12. If I made a x squared plus 4x, I can replace those with an a. So I'd have a squared plus 7a plus 12. Now, doesn't that look a lot easier to factor? Okay, so what factoring method am I going to use for this?
Box.
Very good. We're going to use a box because it's 3 terms. It's a quadratic.
3 terms.
Okay, so here we are. What goes in the top left box?
A squared.
A squared. What goes in the bottom right?
12.
12. So a squared times 12 is 12a squared. What are my factors of a squared that add up to be 7a? 3a and 4a. Okay, so what can I factor out of the top row? An a. How about the bottom row? Okay, left column. A, and right column? 3. So, my factors of this are a plus 4 and a minus 3.
Plus 7a plus 12. Why do you have a minus 3?
Oh, it should be plus.
Where did you get that? Where did you just made like a parenthesis chunk?
So, I turned this all into an a, this all into an a here.
Why?
So that it'll be easier to factor.
Oh, they're the same thing.
Yep. So now that I've done that, I'm going to replace my a with that part again. So I'm putting it back in. So it'll be x squared plus 4x plus 4.
Oh my god, it's
Yep.
magical.
X squared, yep,
No, wait, no.
plus 4x plus 3. Yep, and then you could put them in a box.
Okay, now you lost me.
So now I'm going to factor this. This one right here goes into a box, right? X squared and 4. So what are my factors of 4x squared? Yep. So 2x and 2x. So this will be 2x and a 2x. So what can I factor out of the top row? Bottom row. Top left column. 2. So this now has become x plus 2 and x plus 2. Yes. Okay. Now I can do that with this one. I'm going to use a different color. Okay. So this is an x squared. This is a 3. So what are my factors of 3x squared that add up to 4? Yep. So we have x, 3, x, 1. So I could break this down into x plus 3 and x plus 1. So this is my final answer here in the box. All right, this is another example of chunking, believe it or not. Okay, so you can reset this up as to be x to the 6th. Oops. Minus 1 equals 0. I'm just bringing the 1 back to the other side of the equation. Okay? And you can actually look at this x to the 6th. This is the same thing as saying x to the 3rd to the 2nd, correct? Okay, so I have a difference of squares here. So what would that be?
What do you mean difference of squares?
So that's like our factoring method when we have the conjugates. Okay? So it'll be x to the 3rd minus 1 and x to the 3rd plus 1.
What happened to the
Because it's squared. This is like saying 1 squared also, right?
Got you.
Okay, so now what do I use to factor these two terms? Huh? Nope. Nope. We just learned it Friday. Sum of cubes.
Oh, then you have to do that x plus y.
Yep. So this is going to be x minus 1 times x squared plus x
Wait,
plus 1.
Oh, and then quadratic x plus
Yep.
then you do quadratic.
Why would it be x minus 1?
Because this is starting off of x minus 1. This one's going to be what?
And then x equals x plus 1.
Uh-huh. And then x squared
plus
minus x plus 1. Okay, then for these two, how would you factor them? Quadratic formula. Okay? So, even though it may look really, really complicated, you can break them down using chunking. Okay?
So like